A wall 50 meters high. For 100 years nothing had ever breached it. Not an army, not a siege, not once. And then one morning fingers appeared over the top. Human-shaped fingers, cracked and steaming, each one 4 meters wide. But here's the strange part, and it's the part almost nobody talks about. Cut off one of those massive arms, and a single kick sends it bouncing across the mud like an empty cardboard box. A 60-meter monster, lighter than styrofoam. That's where today's story starts. Not with how terrifying this creature is, but with a question. Why did this giant have to be light? The answer was written 380 years before the manga ever existed. The year is 1638. Galileo Galilei, old and going blind, publishes his final book. And buried in it is a warning about giants. They cannot exist. Scale a body up far enough, he wrote, and it will collapse under its own weight. The logic is simple enough to do on your fingers. Double the height and the bone's cross-section, the part that actually carries the load, grows 4 times. But the body's weight grows 8 times. Now scale it 10 times. The bone gets 100 times stronger, while the body gets 1,000 times heavier. Strength scales with the square. Weight scales with the cube. And the wider that gap grows, the less a body can carry itself. So what happens to a 15-meter titan built at human density? Watch the first step. The instant its weight shifts onto one leg, the stress inside that thigh bone climbs past the limit that bone can physically survive. It isn't walking anymore. It's collapsing. The geneticist J.B.S. Haldane summed this up in a single line that has never been improved on. For every size, there is a fitting form. And the numbers only make it worse. A 15-meter titan at human density weighs about 48 tons, the same as a main battle tank. But look at how a tank carries that load. 2 long tracks spreading the weight across meters of ground. The Titan has 2 footprints. That's the entire contact patch. But something fails before the bones ever do. Body heat. Heat is produced by volume, by every cell in the body burning fuel, and volume scales with the cube. Heat escapes through skin, through surface area, and that scales only with the square. So the bigger you get, the more heat you make, and the narrower the exit becomes. The furnace grows. The chimney doesn't. Run the numbers and the result is merciless. A 15-meter titan with a human metabolic rate would drive its internal temperature past 200 degrees Celsius, roughly 3 times the point where the proteins in a body cook solid. It would never reach an enemy. It would never even finish crossing the field. It would cook standing there in heat of its own making. Snap your bones walking or boil standing still. Physics offered exactly 2 deaths and no third option. But the author knew about every bit of this. He knew. And he had an answer ready long before anyone asked the question. In the story, a researcher is examining a severed titan limb, expecting tons of dead weight, and instead shouts a single line. It's strange, it's far too light. That one sentence thrown away in a panel quietly solves every physics problem we just watched pile up. Put titan tissue under a microscope and the answer is right there. It isn't packed solid with muscle at all. It's a porous structure, riddled with air pockets, walls thin as paper. It's the same trick used by styrofoam, by a loaf of bread, and by the spongy bones sitting inside your own skeleton right now. Keep the volume, delete the density. Nature worked this out hundreds of millions of years ago. Let's feel the scale for a second. A 60-meter colossal titan has roughly the volume of 18 blue whales stacked together. At human density, that is thousands of tons, a number that simply cannot stand on legs. And yet in the story, this thing climbs onto a wall. It walks, kicks, which tells you the density was cut, and cut drastically. And here the twist flips one more time. Because light doesn't mean weak. Destructive power isn't mass. It's kinetic energy. Mass times velocity squared over 2. Have the mass but double the speed and the damage doubles with it. On top of that, the Titan's body is filled with pressurized steam at 350 degrees. A thruster built into a lightweight frame. So it isn't weak because it's light. It's fast because it's light. And the wall breaks because it's fast. And none of this is a fictional invention. Real giants solved the identical problem. Argentinosaurus, 35 meters long, 80 tons of animal. Cut its bones open and you find them hollow. Like a bird, it packed air sacs deep into its skeleton to shed weight it didn't need. Keep the volume, cut the density. That is precisely and exactly the Titan's solution. But shedding weight is only half the job. You still have to hold up whatever is left. So look at a giant dinosaur's legs. They don't bend. They stand straight and vertical like temple columns. A bent leg loads the joint with bending stress, and bending is what breaks bone. A straight one channels the force cleanly down the shaft and into the ground. It's the same reason an elephant's leg looks like a pillar instead of a spring. Elephants went one step further than that. Compare a calf's leg bone to an adult's, and the adult's is disproportionately thicker for its body size. Not just bigger, but bigger than it should be. Bone thickness was tuned to outpace body growth. Living things adjusted this dial slowly, over millions of years of trial and error. A fictional titan had no such time, so its author reached for density instead. And then there's the heaviest animal in the history of this planet. The blue whale, 190 tons. How does something that heavy move at all? The ocean. Underwater, buoyancy cancels gravity almost completely. And a blue whale never has to hold itself up on legs for a single second of its life. It didn't beat the curse of scale. It moved somewhere the curse doesn't apply. Put a titan in the sea and physics wouldn't complain at all. One piece is still missing. In the story, titans don't eat. They draw their energy from sunlight, and when the sun goes down they simply stop. That isn't a coincidence either. Burning food for energy always produces heat, the exact problem we just watched kill them twice over. Switch the metabolism to sunlight, power the whole thing down at night, and the self-cooking problem quietly disappears. So the Titan's lightness was never a lazy shortcut. Bones that shatter under load, a body that cooks itself, and enough force to bring down a 50-meter wall. One single answer solves all three at once. Make it light. Good imagination doesn't ignore the laws of physics. It learns them first and then goes looking for the gap to walk through.